Alright, welcome back everyone. I hope you got a chance to eat like I did. Um, if you didn't, that's cool too. No judgment. I just don't know how you expect to make these 8 million pound deadlifts if you're not eating anything. So that's it's kind of a mystery to me. I'd like to leave a comment telling me how you plan to do that. So what I want to focus on in this video is these outliers like this 20,000 pounds, 8 million pound deadlift. I want to kind of get rid of those and focus on like these data points down here. What you can do, and this is native plotly functionality now actually, is you can kind of zoom in on these here. So I mean that's one way to kind of get to the data that you're actually looking for. You can see there's a huge large concentration of data points in here, but we don't want the user to have to do that every single time, obviously. So if we bring up the code, hold on a sec, code, where'd you go? Alright, here we go. Oops, not split screen. Okay, so what we want to do, we have a function that's already loading the data frame. That's perfect, that's great. We have a function generating the scatter plot. What we want to do is we want to have, I want to make a separate function that will actually clean the data for us. So we'll do a cache data on this as well because we're not going to need to do this every time. And we'll just we'll call it clean data because we're very original over here. And that'll take in a data frame that'll just be a pd.dataframe object. And it'll return pd.dataframe. And the reason I like to do these type annotations too is because it's easier for like developers to look at what you're doing in here. So we'll just say args, let's take in a data frame, which is a pd.dataframe. And we'll just say something like data to be looked at. And so this is creating a doc string too. This is also something that is, it seems very small, but it goes a long way. Anyway, so let me look at my notes. So the first thing that we want to do is we get nan values in the data. So nan stands for not a number. So that could either be null values or just any numbers that can't end up being parsed. So what we want to do is we want to remove that from our data frame. So to do that, we will make a new data frame. We'll call it filter df equals data frame dot drop NA is what we're looking for. That'll drop all the nan values. And then we only want that to act on a subset of the data frame. So we'll use the subset parameter right here. And we only really need that to apply to yeah, these are supposed to go, both supposed to go in the brackets. Weight and deadlift. Okay, so we'll remove that one right there. Deadlift. And then so we have another cleaning process that we want to do too. So we want to put an upper and a lower bounds to each of these variables. So we want to say anything above 1,000 pounds in deadlift or anything below 10 pounds of deadlift doesn't really make sense. 1,000 pounds of deadlift. That's, I think, close to like what the world record is. So that might leave out like, Eddie Hall or whoever holds the actual record for right now. But we've conversed about it, and he's okay with being left out of the data set here. We also want to do the same thing with the weight too. So we want to say that anything that is, we want to look at athletes who are only under a certain weights of 500 pounds, just for viewing purposes. And filter data frame. And then our upper bound for the deadlift, as we said earlier, is going to be 1,000 pounds. And then what we're going to do to make this easier, because we also have to put in the lower bounds, we have to put in another line for that, is we're going to do another ampersand here for an and statement, and then we're just going to copy and paste that because most of it's going to be the same. We want to look athletes over 100 pounds and whose deadlift is over 10 pounds. Whoops. Get rid of that. Okay. So now we want to only take a subset of this. So we want to just take, we'll just say we want to take the first 1,000 rows of this. And so the way that we're going to do this is we're just going to say filter df.head 1,000. That's just going to take the first 1,000 rows from the front and then return that. Okay. And then so down here we want to make another line. We'll say df.clean data. And pass the data frame into that. We can do a name parameter too. So name parameter is just, it just makes it a little easier to identify like what it actually is. We'll go ahead and just do the same thing here too. So we'll save that, and then always rerun, that's fine. Then look at that. Okay, so we're only here now. Alright, so back in our code here, what I want to do now is I just want to show some of those statistics. So this will take advantage of an actual Streamlit widget called, or a few Streamlit widgets actually. So we'll use Streamlit. We want to make a checkbox. So this will be that checkbox that I was showing you at the beginning, which will just say show statistics. And by putting this if statement here, we're saying that like if the user has clicked this, then we want to show whatever's inside this code block. So what do we want to show? Well, first we're just going to put in a subheader that says, we'll just call it averages, because that's all that we're going to put in here for now. And then we just want to actually show those. So what we're going to do is, so Streamlit, you can also use Streamlit.markdown, which you can put any markdown that you want in there, which is actually a really nice feature. So putting a double asterisk surrounding anything will make it bold print. So what we'll do actually is we'll put deadlift here, and we'll put that in bold. And then, you know what, before this, let's make this into an F string so that we can put our data in here. So, df deadlift. And we can just use the .mean function here, and then this gets the actual mean value. So, and then I'll just copy paste this here and put in weight with, oh my gosh, I did that last time the other way around. Maybe I need an app. Wait. Okay. And then if we save that, go back to our app, then we should, so we click this checkbox here. Yep. So we see deadlift. The average in this data set is 419, which, I mean, does make sense looking at the data. That seems a little, I mean, just speaking as like a CrossFit athlete, that does seem a little high, but I don't know, maybe these are some good people. The average weight is also more than I actually am. Let's see, what else can we do? Because we want to only show this to 2 decimal places. We don't really need it all the way out there, so we can use a formatter, string formatter. So we'll just do :.2f. That should be it. And actually, let's put it in a label for each of these too. So we'll say pounds and pounds. That'll just make it look a little bit nicer. Okay. So now we only have it as pounds and only at 2 decimal places. So what else I showed you before too is we can have like a trend line going through here. So that is, Plotly does have that functionality, but you actually need to install something else, which I will do in a minute. The way that we can do that in the scatter plot though, in Plotly, is there's a parameter called trend line. So do what is it? The OLS for ordinary linear squares. Yeah, whatever it is. Whatever that statistical method is called. So we want to save that and see, we get a message here for no module named stats model, which if you go to the Plotly documentation, it says that you need this. So we'll do pip env install stats model. Oh, you know what? That's why. It's stats models, not stats model. That's why it gave me the error before too. Okay, so take 2, go back, pip env install stats models. I thought that error was a little bit strange. There, now it seems like it's working just fine. Alright, so now pip env run dev. And there we go. Alright, so how we can interpret this then is the R squared value. Think of that as like the correlation. So how much does your weight impact your actual deadlift score? And it's usually between it's always a number between 0 and 1, with 1 being a strong correlation and 0 being almost nothing, if nothing. So 0.7, that's a very low number. So it's saying that, weight, according to this data set, weight doesn't really have that much of an indicator on your deadlifts, which is kind of true. I mean, there are like a lot of other factors that go into it, like genetics and all that kind of stuff. I mean, keep in mind this is really kind of a random data set, and by cleaning the data, we felt also almost cherry picked it. The deadlift equals 1.2 times weight plus 192. You can recognize that from school as like the formula for slope. So the 1.2 that you're seeing, that is that's the actual coefficient. So that is saying that approximately for every pound of weight you gain, it's approximately 1.2 pounds in deadlift, which doesn't really make all that much sense. And then the 192 that's where it crosses the actual y-axis. So it's saying theoretically, if this trend continued and there were like a 0-pound person here, then they would be able to do 192 pounds, which is also something I don't think is necessarily accurate. But again, this is a very cleaned up data set and still kind of random. But I'm glad we got that in. So that takes care of this video on setting up the actual scatter plot, and thanks for watching, and I'll see you in the next one.